Hey folks, welcome this Friday afternoon. A great specialized segment today coming your way. I love to hear when I hear that music going on, and I know today we are going to get to enjoy working some good old problems out together. It's not a call-in day, and by the way, I am Ernie Roberts. I am your host for TNLearn Mathline today, and we're going to have a great time on the show. Be sure you get your pencil, get your paper, actually get graph paper ready to go with yourself this afternoon, all right? And we are going to have some looking at the coordinate plane, all right? Let's see where we're going on that coordinate plane business, all right? Let's see what our title is today. It says this solution covers some major space. Now we're going to be graphing linear inequalities today, and what we mean by the major space is we're going to have to shade above or below our lines and perhaps even a little left and right, okay, depending on what the setting of the problem is. All right, so let's take a look at our first example. Get ready to go with it here, and we're going to let it slide right down with you, all right? Let's see here, coming down to us. There it is. We're going to graph, we're going to be graphing today, and we're going to look at y greater than -3, all right? That's our start. Now, a lot of things I want us to notice on this. First of all, got a lot of questions. One of those is going to be, the first one is solid or broken. That's our line. And I've already circled it for you, all right? I've already told you we're going to go with broken on this. Why? Because we do not have an equals to as part of this inequality. It's just greater than -3, not greater than or equal to. So when it's greater than, we go with a broken style of line, okay? That's our first question we're going to be asking. Next question we're going to ask, what's the slope of this line? It's still like a y equals, all right? If it was said y equals -3, you would say, hey, the slope is 0 because there is 0x going on there, all right? So with the -3, you've got that is going to be an intercept. That is not your slope, not your slope. Remember, your slope's always got to be next to x. We see no x, so we call it 0. You got it? Go with 0. Next question, I think I already answered for you, was what is the y-intercept? And that is a coordinate, a nice point there. And that is going to be at 0, -3, which is all you see right there. It's all you see. So by the way, this line, how is it looking? If it's got a 0 slope and it's passing through 0, -3, it is horizontal. It's rolling horizontal. It's not vertical. It's not diagonal. It is flat. It is flat. It's going at a slope of 0. It will be horizontal, completely horizontal. So, one more question we've got. Oh, which direction are we going to shade? I mentioned that earlier in the opening of the show. Which direction do we shade? And you know what? We're going to shade above because of the greater than. And we'll see how that works here in just a second, all right? Let's go ahead and get ready to graph on this, all right? Thank you, guys. And we're going to pick up a nice little coordinate plane here, and we are going to show you what we're talking about with all the good things here. We've covered them already, set them up. This one is y greater than -3. I'll put that right down there at the bottom for us, okay? Now, let's see where we're going with this. First of all, I mentioned the intercept, and I mentioned the slope. Those are usually good things to do. Our y-intercept, folks, that is at -3, so we're going to count down 3. We're going to count down 3. Right there it is. And we said that it's a flat horizontal line since the slope is 0. So here we go. We are going to throw this one in there. And by the way, remember what I said? Broken. So let's sketch along the way here. It is a line, so we put the arrows on the end, and we're running it right through that little margin, right through there. Now, that's nice. We got a broken line, but the big question is, where are all the other points? Because remember, we have many, many points with an inequality. You're going to be able to satisfy this situation, and they're all above here. So we're going to shade away from that broken line. We do not include it. We get as close as we can. Sometimes we get a little closer than I like to, but you get the idea. It's all this space back in here. Some of you like to go and darken it all in. That's cool, all right? But this gives us an idea that it is above the line. Those are all the solutions here. So we're graphing solutions. We're not going to really talk much more about them except that that is the line y equals 3. It's broken because we do not want the equals to be part of it. And then we're looking for greater than, which takes us above. So there's your first problem. There's our first situation. You say, well, you like that. I hope you do. Hope you do. Because it's a lot of good fun stuff coming up here. So let's take a look at our second one here. Let's take a look at the second problem here. First of all, this one says x less than or equal to 2. All right, so we've got some different thoughts here. By the way, you say, well, Ernie, where did the y go? We don't have y on this one, do we? So when we're talking about x equaling 2, folks, it's a vertical line. It's a vertical line. So we're going to start thinking about vertical, and things less than 2 should be to the left of this line. So it's a little different thing. Now, the next question asks solid or broken. Remember, I gave you a hint in the last problem. Solid goes with an equals to. We've got it. So there's what we're going to do. This time it's going to be a solid line. Not because of the less than, but because of the equals to. All right, the less than is just going to tell us which way do we shade, which way to shade. What is the slope? Remember I said vertical line. You say, we can't figure that out. You're exactly right, you can't. It is undefined. It's undefined. So we have an undefined slope here, right there, all right? So that's an important moment. What is the y-intercept? My friends, there isn't one. There is none. This is not going to ever tap into the y-axis, all right? So there is no y-intercept. And which direction do we shade? Since it's less than and this is a vertical line, this one is going to be all about shading to the left, all right? So again, we check back through this. It's less than or equal, to, so it's going to be solid. We have an undefined slope, which means vertical line, and it will be a solid line, by the way. And there is no place it crosses the y-axis. So let's see how this graph pans out, what it looks like, all right? Let's see what we've got here. Let's get a graph right in here. And here we go. Let's see, we got, good. Now, this one said x is greater than, nope, it was less than, right? Less than or equal to the number 2. All right, so what are we going to do? We're going to find x equals 2. Right there it is. And as I said, it's a vertical line. This is an undefined situation, and it's solid. It's going to be solid. So let's make it solid through here. Try to get that as vertical as I can. There we go. And since it says less than, we shade out this way to the left. Try to get as close to the line as you can. You obviously don't want to try to go across it, but that's the idea. That represents all this territory would be. It would be nice if you could just go, darken it all the way in there. That's fine. But it is a left situation there we're shading this time, all right? So those are the cases. If it's y equals or x equals, remember those were giving us either a horizontal or vertical line. Now, if the equals is there, you keep it solid. If it's not there, you make it go broken, all right? So, and just remember, x is vertical, y by itself is horizontal. Those are your great stories. So what happens if it's not vertical or horizontal? Here's our game plan, all right? Let's take a look at this. This time we're saying y is greater than negative 3x plus 1. Ah, there's that y and mx plus b, all right? You remember the good old formula for slope-intercept. We're still going to do that. We're still going to use the line. If you can do slope-intercept, you can graph these things. But what we have to determine is when we're thinking about where we're going to graph this line, we need to make sure it's either solid or broken, and we want to follow that from the beginning, all right? Because especially if you're using a pen, and hopefully you're not. If you got a pencil, you can fix that. You can always fix it. But with me up here with a pen, I've got to make sure I get that decision right from the beginning. It is definitely going to be broken because I don't see an equals to here, all right? That's the simple thing you're looking for. If you got an equals to, it's solid. If you don't have the equals to, you're going to be broken, all right? What is the slope? Well, slope is always what's next to the variable x. We have an x and we have a y both, so we definitely have a good slope here. Our slope is equal to negative 3, which we can also write negative 3 over 1, all right? Where's the intercept? Remember, that's your intercept out here, that b value, and it's going to be at 0, 1. And you say, well, which direction are we going to shade, Ernie? Once we graph this line, it's going to be on a slant. It's going to be on a slant. And what we're going to worry about here is pretty much with greater than, since y is leading us out, we're going to go with greater than. Now, there's a rationale. You can put a 0 and a 0 in there and show whether it's going to work or not, all right? And you say, well, Ernie, what's that about? We'll look at that option here when we draw the graph here. But which direction? I'm going to go ahead and tell you. We're going to basically be going above the line. Now, remember, diagonally, it's going to look a little bit a bit above and below, and also left and right, but you've got to let the above and below win you over, all right? So let's take a look at how that's going to look when we graph it out, all right? We have the inequality is going to be y greater than, looks like negative 3x plus 1, all right? And remember, we've already found the slope. We've already decided we're going to use a broken line. So what we need to do is figure out what's going to happen with this line. You know, we're going to put something down there. So we're going to first of all start at our intercept, just like we would always graph. We would start at the intercept, which is at positive 1. That's on the y-axis. There we are, 0, 1. So we start with 0, 1. And then remember, our slope is negative 3 over 1. So we're going to go down 3 over 1, down 3 over 1 one more time. And I'm kind of off my graph. You may want to take it a little bit further. And let's connect those. Get a good old straight edge there, always helps you out. And this one is cutting through, basically it also passes through that point. So here we go, it's broken. So we break it down and we send it down here. It's going to keep going. And there we go. All right. That is an arrow down there. Boy, it is a crazy looking arrow. There we go. Better. And again, now the question is, where are we going to shade? Now I said something about if we put in zeros here, if we put in 0 and 0, in other words, the origin's right there. If we put in 0 and we put in 0 over here, question is, will that make a true statement? Well, let's see what happens. -3 times 0, we know goes to 0. That's why we picked 0, 0. And we've got 0 greater than 1. Now, the catch here is, that's not true. That's false. And you say, Ernie, what does that mean? That means this origin is not a good point. So you want to shade on the other side of your line that you were creating here. Remember, we have this line. I'll put a little bump on there also that keeps going on. So what we're wanting to do is we're going to shade, and I said would be above the line. So basically, if you look at how this is basically in a vertical mode here, it is going to take you this way on this diagonal is going to be above that line, okay? This part would be below. And remember what I said, this was a bad point, so you don't want to shade that way. So usually, by and large, if you got y by itself, pretty much, it's going to be a shade above the line, okay? And sometimes that's a steep line. So again, notice it is still going up from those points right there. So you take it that direction. Take you in the positive manner, okay? So that's our story here. So sometimes it's horizontal, sometimes it's vertical, and sometimes it goes another direction. So let's see what happens on this one here, all right? Here we got graph y less than or equal to, oh, that's a hint right there, that equals to, and that's 2/3 x minus 1. We're ready to kick with this thing. Question marks, let's go through it. Y'all go ahead and answering these questions, I hope, at home. You've got solid or broken. Well, there's an equals to. So here we go. We're going to do the solid version, all right? What is the slope? It's the number next to x. Now, this is a whole slope. The way this is written out, this is 2/3. So our slope in this case, our m as we like to call it, is 2/3. It's positive. It means the line's going to look positive to us, all right? And what is the y-intercept? At 0, -1. We're all ready to go. Which direction will we shade? Less than, I tend to say we're going to shade below because the y is leading out, all right? So when the y leads out, it's either about greater than is going to take you above, less than is going to take you below, all right, when the y is leading your way. So let's do a graph. Let's see what happens, all right? See how we're going to work this one out. Pull a little graph paper in here for you guys. And let's see the equation, inequality that is, less than or equal to 2/3 x minus our 1, all right? Minus our 1. Take a look at this. Now, we are at -1 to start off with. That is your intercept. Remember that? We start with the intercept to graph. And then we take our slope, which is 2/3. And by the way, what does that mean? It means we go up to right 3, up to right 3. So in other words, we're both going in positive direction. These are both positive numbers, so we're going to go up with our rise, and we're going to run to the right. All right? So there we go. So let's add them up and see what happens here. See where these points take us. We go up to over 3. Up to over 3. And I can push one more in there. Barely get it in there. Notice those points are lining up beautifully. They're supposed to. Now remember, got an equals. Got an equals. Y'all ready with me? All right, you out there? We're going to make that solid. We're going to make that solid. And it'll look good if I can get it go here. Oh, let's see. Can we get it? There we go. Right there's where I want it to slice. Looks pretty good. And put your arrows on that. It is solid because of the equals to, all right? Now, this will keep going on, all right? This line keeps going on. Don't get confused about that, all right? Now, this time we're talking less than. I can run my 0, 0 here real quick for you. And I got 2/3 of 0 minus 1. According to this, 0 is less than -1 or equal to. That's not true. That's false. You say, is it always going to be false? Well, if it's false, you just don't include the origin. If it's true, you're going to include the side that has the origin. And remember what I said. That's over here. So we're going to shade below, and I believe that's what we decided over on the other side here, all right? So here we go. Shade it on in there. And got to understand, this just keeps going on and on. You've run out of space here because my picture gets in the way, and we've run out of space down here. Well, we just got it. But the idea is this keeps going on and on. These streaks would just keep going, depending on how large your graph is, how much you're trying to incorporate there. But you want to make sure we try to stay south of that line, okay? So it would be below it. It will be below it there. Okay, and there we have it. You've seen a less than, you've seen some greater than, you've seen some equals to involved, you've seen some not so equals to involved, all right? So let's look at another one here. Let's take a look at our next one here. Oh my goodness, look at this. I'm going to write this down because we're going to need a little bit of work on this. It says x plus 3y greater than or equal to 6. You say, Ernie, why do you want to do that? Because I don't have y by itself. I've got to get y by itself, all right? And that's what we're working toward here. That's what we want to get to, slope-intercept, all right? So looking at this situation, what's keeping me from having y by itself? Well, I see an x that's in the way. I see a 3 that's in the way, all right? So let's do some work on this. We'll subtract x. We'll subtract x from both sides. Remember, you got to do that. Now, by the way it is, it's the subtraction property of inequality here, all right? Y'all hear me say the equality a lot, but it works for inequalities also, all right? So let's see where we're going. We got 3y greater than or equal to, let's put the negative x in the front, all right? Plus 6 on the back side, because that's going to allow me to get my slope and intercept here, all right? And when we get that divided through by 3 everywhere, we are going to end up with y greater than or equal to, it looks like, I'm going to put a 1/3, all right, a negative 1/3 x, because there's a 1 in front of that x. We're going to make a fraction so we can get a good slope out of it. And oh my goodness, 6/3, let's make that as easy on us as possible. That is worth 2, all right? Let's make that a nice even number. So now we've got it going here, all right? First of all, is it solid or broken? We got to look at the greater than or equal to. Hey, that equal to is the key right there. Go solid, go solid. What is the slope? Well, it took us a while to find it, but it looks like it's going to be what here, my friends? It's going to be negative 1/3. So our slope equals negative 1/3. That's going to be important to us. What is the y-intercept? Right there. It's the number on the end. 0, 2. And which direction are we going to shade? I've been telling you pretty much if it's greater than, it's going to be above the line. We're going to see if that holds true again, all right? So we'll get ready to graph it here. Let's see what happens. We got some good stuff going there. I hope you're getting the idea here, all right? It's basically the questions I'm asking you are what you have to ask each time. And once you answer those, it's easy to graph them. Now I'm going to pick up where we left off. You say, where'd you leave off, Ernie? We left off at y greater than or equal to that negative 1/3 x, and we have a plus 2. There we go. That's where we finished up. That's where we're going to start our graph, all right? Now, again, remember we said it's going to be solid. It's going to be solid because of that equals to moment going on here. So let's start at 0, 2. Remember, that's your starting point. And our slope, in this case, is negative 1/3, or 1/3. Now, let's take a look at where we're going. We're going to start at 0, 2, and that negative 1/3 tells you we're going to go down and to the right. Okay, so we're going to go down 1 to the right 3, down 1 to the right 3, and I could keep doing that. I'm going to run right into the edge of this, but you get the idea. All it takes is about 2 or 3 points to make the line look really good for us, all right? So let's connect. Let us connect here. Ooh, back that way. Down this way. Maybe we could keep it going and going. You get the idea. And what did I say about greater than? We should be shading above. So that means 0, 0 is not going to look good for us. Let's check it out. We got 0 greater than negative 1/3 times 0 plus 2. You guys, we all know that 0 is not greater than 2. Or equal to. So that means this is not a good point. We're going to be on the other side of this line. And as I said, that means we're going greater than. We're going to go greater than. So here we go. Let's shade it off that way. And there's your situation. Again, remember, major solutions here that we were talking about in that opening. It's a lot of coverage, okay? It's going to go on and on and on and on. We just stop because we can only take our graph so far, all right? But keep in mind, this shading is continuing on and on and on. That way, many, infinitely many solutions popping up in your head over there that'll work. There are also lots that don't work. So be careful. Be careful when you're saying, gee, are all the answers good? You got to check and put them in the answer in that equation or inequality and see what it's going to give you. See if it's true or false. Speaking of which, let's look at our next one here's going for us here. This one says we're going to graph 3x minus y greater than negative 3. And what I want to do, let's go ahead and work this thing out a little bit. How about it? We got 3x and we got minus y. This time it's just greater than negative 3. Now, just because you don't like the problem doesn't mean you got to put an equals to it. You can't do that. Got to stick with what you got. All right, stay with where you are. What you've been dealt, you've got to use it. All right. Let's move this 3x. It's going to be subtracted, both sides. Good old inequality moment here. And we have negative y, or opposite of y, however you want to look at that, as a greater than, negative 3x minus 3. Folks, don't, even though I kind of lined those up, I should have probably made them a little, really not much room to space them out. But remember, they have to stay separated. They're not like terms, all right? So don't try to combine them. Don't become negative 6x or something terrible like that, because you won't have the right answer, all right? Now, here's what you got to be careful with. You've got almost y by itself. What's keeping us? Well, there's a negative 1 hanging out in front of the y, all right? So what we're going to do, we're going to divide everything by negative 1. And that's going to change a lot of signs. It's going to change y to just y, okay? It's going to give 3x, and it's going to give me plus 3. All of a sudden, this looks like, wow, everything's gone positive. But you know what? If I'm changing these signs, yes, I have to shift the inequality. Remember, when you divide or multiply by a negative number, you've got to let that inequality change directions along with your signs, all right? So, it works when you're graphing on the plane, just like it worked when you did it with small equations or compound inequalities, all right? You've got to be alert to that, Otherwise, you're going to be shading on the wrong side. Be on the wrong side. Now, speaking of which, let's go back and answer our questions, all right? We've got everything we need at this point, don't we? I hope we do. We are solid or broken? I see no equals. So we are broken. All right, there you go. What is the slope? Well, it pops up as 3. There it is. So m equaling to 3. There you go. All right. What is the y-intercept? Well, it's also 3, but let's make sure we put it as a coordinate form. Not to get you confused, that slope does go along with the problem there. We'll move right down there. Which direction will we shade? Less than usually tells us we're going to shade below. We're going to be shading below. So looks like that's going to be our direction. We're going to be below that line. And again, it's broken. So let's go to graphic. Let's see what we're going to have with the graphing on it, okay? Pulling in our graph paper, going here. And what did we end up with? We'll pick up where we left off. How about it? Y less than the 3x plus 3, all right? So here we go. This is kind of nice. As we start at 0, 3, so we're going to count up 1, 2, 3 on the y-axis. Remember, you always start on the y-axis. That's a y-intercept there, okay? And we've got a slope that's telling us we're going to do 3, and we're going to do 3 over 1. So we're going to rise 3 and run 1. And you know what? I'm out of room. So let's do something else. We can go to negative 3, going down, and we can go left. You say, Ernie, how can you do that? Because a negative 3 over negative 1 is the same thing as a positive 3 over positive 1, all right? Because what happens when you divide two negatives, you get a, yes, you got it, a positive, all right? So we can back it up this way. Let's do one more round. Why not? You can always do that. And it's going to create a nice little line setting for us here. And see where it's taking us. Is it solid? It is not solid. You know what, Ernie, you did that wrong. So we need to come back along there and let's break that. See what happens? That's what I told you. We need to worry about it. We're going to make this thing broken, all right? That's what it's supposed to be. Sometimes you forget. Sometimes Ernie Roberts forgets too. But it's going to be a broken line through there, okay? Not the solid. So it is a broken line. I want to make sure everybody knows that, who might just be tuning in and say, what is that? It's a broken line, okay? Now, does 0, 0 work? That's the question. Put a 0 in here, we'll see. 3 times 0 plus 3. 0 this time is less than 3, so our shading is going to take us, and I'm going to just take it up to the broken line there. It is going to take us in the manner where the thing is there. And remember I said it would be below. And you say, well, that's almost kind of going right. It is predominantly right, but it is still below that line. Still below that line in terms of the y. So there's your shading. There's where you go, and it is a broken line. Thank you, folks, for getting a little forgiven on that one, all right? Be careful when you do your shading. So what's going on today? We have picked up on the basic rules for how to put a line on a graph, whether it says greater than, less than, greater than or equal to, less than or equal to. There's a lot of shading going on. It covers a lot of major space out there, all right? So your solutions are not just the lines and not just a number or two. It's the shading. It's a picture. It's all about the picture in there, okay? So again, we love it. We love it. These kind of problems make things are fun. And we do want to remind you that you can still catch us on Facebook. Like us there. We love it when you like us there. www.facebook.com. TNLearn is where you're going to find us. Also, email us, mathline@tnlearn.com. And about YouTube, hey, this will probably be on YouTube, and it's good for you out there. So you know how to find that on your good old online surfing. Hey, thanks for tuning in. We'll be back again live next Monday, and look for you then.